Excellent. Well, thank you, Chuck, for that introduction. Thank you for putting this presentation together. My name is Rick Bidlack. I'm with Wheatstone. I am also being joined, I believe, by my colleague, Jeff Keith, who is the designer of the audio processing suite that I want to discuss today. So let's kick this off by laying some groundwork. Streaming is here to stay. It is not going away. Half of the US population listens to streamed audio every single day. Another 20% are listening at least once a week. Smart speakers are pretty ubiquitous now. They've made listening to streams in the home a part of our everyday normal activities. Last year, there were almost 160 million, excuse me, smart speakers being used in households around the US. Smart speaker sales have more than doubled in the last 2 years. Streaming accounts for almost half of all smart speaker listening. So if you are despairing as a radio person, if you are despairing that maybe streaming is taking over, there are in fact some encouraging signs in all of this. 2/3 of people who listen to streams are actually listening to their local radio station stream, which is better than Pandora, YouTube, Spotify, and iHeartRadio. Almost 40% of smart speaker owners use them to listen to their local AM/FM station. People spend more time listening to broadcast radio than they do interacting with any other medium, and this surprised me to learn this. That includes Facebook, Netflix, Amazon Prime, Instagram, and YouTube. So, where are we today? Radio is still relevant. Radio stations are still relevant. Never more so than times like now. Young people especially prefer media that they do not have to pay for, and that means radio. Almost all stations today have at least one stream, and we've been seeing in some of these other presentations that many are leveraging HD radio to create not only multiple streams, but multiple radio streams as well. And yet, some stations out there are still using old on-air based processor technology for their streams. Let's talk about broadcast processors just a little bit. The success of design in broadcast processors has evolved around how they balance a lot of competing constraints. Among them, the laws of physics, the laws of the FCC, or if you're outside the US, the broadcast authority of whatever country you're in. The need for pre-emphasis, the loudness war that we've been witnessing over the past couple of decades, and the consequent necessity for a clipper on the final stage. You've got the 15 kilohertz brick wall, you've got the pilot tone, you've got the MPX, you've got the HD, you've got the RDS. All of those things contribute to making a broadcast processor a complex piece of machinery. And there are a lot of competing factors that are adding intermodulation distortion and artifacts. And of course, there's a lot of brilliant designs out there. I don't mean to denigrate anything, but it's a complex piece of gear made for a specific purpose, which doesn't really apply to streaming. So we have been, Wheatstone as a company has been making broadcast processors for a long time. And so we've been thinking about it some. We realized that we are not the first company by any means to build a processor for streaming. But for us, this is an opportunity to sit back and take a new approach. So we don't apologize for that. Our chief process designer, Jeff Keith, has been thinking about some things for a while. The only real constraint that you have in streaming is the size of the pipe between the server, which is serving the stream down to the audience, and of course the device you're listening to. This bandwidth that's available or not available has been and continues to be the primary driver in the design of data compression codecs. So you might think of the codec as the sort of streaming analog of the physical difficulties of putting out an FM spectrum, an MPX signal out there. The role of the processor is therefore to present the best possible signal, the best behaved signal to the encoder so that the encoder can do its job. So when we started thinking about processing for the streaming age, we had multiple goals. We want to present as consistent a signal as possible to the encoder, meaning that the long-term level it remains consistent as well as the short-term compression levels. We want to adapt intelligently to changing program content. In other words, as you're going from one song to another, or as you're going from, say, a song block to a news block, things like that, you want the processing to change and adapt accordingly. We want to provide peak protection without ever clipping. We want to be as transparent as possible, and by that what I mean is we don't like to hear the processor working. We want it to work without hearing it work. Unless, of course, you like the color of hearing things work. And in that case, if you like the radio punch, the 70s sound, the 80s sound, if you like pumping or wheezing compressors, flutter effects, things like that, then you can actually get that from some of the processing that we've created. This slide here is to show you some of the things that we are trying to avoid in the StreamBlade processor. For example, if your compressor is too fast, if the time constants are too fast, you're going to end up creating some blur in the signal as opposed to adaptive compression, which we've built in. This blur makes it difficult for an audio encoder to actually do its job because it's spending a lot of bits encoding the blur and not the program content itself. Another issue that comes up is control over the stereo field. We of course want a beautiful stereo field, what we're seeing here in the middle. Excessive stereo is kind of akin to color saturation. Too much of a good thing is not really a good thing. And of course, if you lose your stereo completely, you end up with a very washed out effect. So we're trying to control all of those things and keep everything very finely tuned. So the sort of 20,000 foot overview of the StreamBlade processor. It's a 3-stage process. It starts out with a 6-band parametric EQ. Goes next into a 5-band neural network driven AGC, and finally a dual band IMD free limiter. So the idea behind the dual band limiter is that the base portion of the signal is being limited separately from the upper frequencies, the upper bandwidths in the spectrum, so that the limit effects that get applied to the base are not punching holes in your in the upper bands. So this is a view of the parametric EQ. You saw actually a version of this earlier in Robert Ferguson's presentation about some of the remote applications that we have at Wheatstone. So low pass and high pass filters, high and low shelving, 4 bands of band pass in the middle. We often bypass this entirely, but it's there if you need it to sculpt your own sound. The next stage in the process would be the automatic gain control. So this is a 5-band control. You have individual knobs to control the mix. You have 3 knobs on the side, which are group controls, which are applied to each of the 5 bands proportionally, depending on the actual preset that you're using. I'll talk about presets in just a moment. So the speed control is it's a control over how the long-term leveler works, how quickly it adjusts to changes in long-term level. The density control is essentially the amount of short-term compression that you want to have active at any one time. And the gate threshold is it's a very interesting parameter that governs the transition from one program source to the next. So its primary job is to basically freeze the processing where it is, at the level that it is, once the program level drops below the gate threshold that you dialed in. So it just freezes there and holds it in place until the next program source starts, at which point the compression, the dynamic processor kicks back in. So this aids in transitions from one song to the next, or talk to song or song to talk, anything like that. The final portion of the processor is the dual band limiter. There's actually 4 limiters in this one tool under the hood. So you're seeing the attack, release, and threshold controls for the last of those limiters. There's also a separate base limiter, and then there's L plus R and L minus R limiters as well under the hood. You can dial in the bass enhance, tone it down, tone it up. You can also enable mono bass, which can help a great deal, can help encoders a great deal by reducing the width of the stereo field. So this is an overview of the entire user interface for StreamBlade. You have seen already, I've shown you the DSP portion. You notice there's also enable, disable buttons there in the upper left corner of each one of these modules. So you don't have to have all of the modules kicked in at any given time. You can pull things out if you don't want them. There's a section for setting a preset. StreamBlade is going to be delivered with something like 40 different presets, factory presets already built in. You can tweak those to your own desire and save those as your own custom presets. You can always reload one of the factory presets after tweaking. What I mean by that is if I load in one of these factory presets, then all of the knobs and everything go to those settings. I can then tweak those knobs, like the mix controls, the group controls, the limiter controls. I can tweak those. If I don't like what I hear, I can just hit reload and come back to the preset that I had loaded originally. We have input and output gain meters and input and output gain control. Down at the bottom, this is now we're leaving the realm of signal processing. So we are now talking about the stream destination. Each of the destinations, or excuse me, each of the streams, the input streams, has up to 4 destinations. So you see that the buttons labeled 1 through 4 there in the upper left corner of that box. So this is where you put in all your information about the server that you're sending the stream to, which codec you want to use, the bit rate, which NIC you're using, which transport protocol, etc. There's a copy and paste button there, which are very useful for copying all the settings that you have for one destination to another destination so that you can just make incremental changes. On the right side of this box, you see a metadata output log. So what this is a continuing stream that's showing you the metadata coming in from your automation system, for example, and how it's being transformed to go out to the server. And by the way, you might notice most of the URLs here that I'm showing you, and I'll show you a few more, are talking to a server at StreamGuys, and I'd just like to thank them. They've been very helpful working with us while we've been developing and testing the software, and they've provided a number of different kinds of servers that we can throw our streams out and just see how they behave and what they sound like and what's required to actually connect to them, the various connection protocols that are involved. So I'd like to thank the guys at StreamGuys for that. I'll talk a little bit more about this metadata in just a moment. So let me show you the last section of the interface, which is what I'm calling the master section. So you see the 8 stream selection buttons. Those correspond to the 8 input sources that you can have. These little LEDs that are built into each button are very useful for getting a very quick sort of status report on how everything is going. So the little green dots on the left side of the button, there's only one that indicates that the source is running okay. Notice in stream 6, the source is it's actually inactive, so that stream is inactive. Then the LEDs on the right side of the button correspond to the 4 stream destinations that you can have. And they simply are reassuring you that the output stream is running, that it's active, and everything is okay. By selecting those different buttons there, every time you select one of those, that completely changes the rest of the interface and shows you the current current status of whichever stream you've just selected. So in other words, each stream can have different different signal processing being applied. It's going to different destinations. It handles metadata differently, etc. Down in the lower portion of the master panel there, you see all of the access points for the various utility functions, how your network is set up, what you're listening to, how you're dealing with metadata, which I'll show you a view of that in a moment. You can set up mail alerts, for example, to send you a mail alert when a stream goes down or when there's a error, any kind of warnings that come up. The scheduler allows you to change your DSP presets according to weekly, daily, monthly, or even one-time schedule. And of course, everything is logged and everything is tracked that you do here. The metadata system, metadata configuration, looks like this. Metadata is kind of a special thing. It's still very difficult to deal with because there is no industry-wide standard that everyone adheres to about how metadata works or what it should include, or even what the various parts of it are called. And so what we've discovered, and what I'm sure you all have discovered as well, is that metadata can be produced in pretty much any form that you can imagine. And the server that you're sending your stream to is expecting it in all kinds of different formats, none of which are standardized. So the problem for us as designers is we don't know what format your metadata is going to be arriving in, and we don't know what format you are going to want to send it out in. So the solution that we've adopted and many other people are adopting in not only in broadcast, but in many other fields where similar kinds of problems exist is we've adopted a scripting language called Lua, and we give you a script here. We give you a choice of a number of different scripts, and you can edit these, and all they're doing is ingesting textual data coming in the form of TCP or UDP messages. And the messages are in a particular format, and you need to be able to reformat them as something else and then send them out. And so that's what this is doing. You can choose different filters. They're called transform filters. You can edit your own. You can use one of these as a starting point for creating another filter. So it's a fairly flexible system that we have going on here. So all of this comes in this box, the Stream Blade. So to recap, you've got 8 stereo inputs. Those can be any combination of our own WheatNet AoIP or AES67, or up to 4 analog and 4 digital inputs. If you already have a WheatNet shop, a WheatNet system, then of course this is your bridge into the world of streaming. This will go directly from your WheatNet system into the streaming world. Connection to your content distribution network. You will, like any blade, you can see the Stream Blade in Navigator and make connections there and route signals as you need. To summarize this, I'm probably ahead of schedule, but we'll have plenty of time for questions at the end then. Each ingest stream can be encoded 4 different ways and sent to 4 different servers. We're supporting HLS, Icecast, RTMP, and also RTP for you're not going to use RTP for your CDN, but you'll probably, if you need to do point-to-point transfers or things like that, then it's quite useful for in-house applications. We have a Lua transformation filter system for handling metadata. We have the native GUI, which I've been showing you, as well as a remote Windows GUI. We are currently in beta testing in a couple of facilities, both in the US and overseas. The Streamblade will be ready for sale later this summer, and we're very happy with it and proud about it. And that's basically all I wanted to say. Please contact us with questions. Oh, I want to say we are running currently 8 streams, so you can hear what the processing sounds like at different bit rates. Contact us, please, if you want a URL for those streams, and we'll tell you some more about them, or if you have any questions for us of any sort. So at this point, I would like to sort of open it up to questions. I think Jeff Keith is also
He's online as well. Yep.
Okay.
Yep.
I'm here. Yep.
So if anyone has any questions about the streaming algorithms, please ask, or anything else we can help with.
Thank you, Rick. That was really, really interesting. How many streams can one of these devices handle?
Well, in theory, that would be 32, so 8 times 4.
Okay, and you said the ship date is sometime in the summer. Is that right? These
That
are
is
the questions that I'm seeing online.
Yes.
One other question, and I don't know if this is for you or Jeff. How should a stream be set up? In other words, when you are configuring an audio processor for FM, for instance, FM analog or digital, you have to consider that the ambient noise environment in an automobile, for instance, where a typical listening place, requires compression of the audio. You can't have the same kind of dynamic range as there might have been on some of the original source material.
Right.
How do you see source material, or the setting up of a stream being different, or is it?
Well, it's different because it's a stream, so you don't have the constraints you have with FM. You generally do not worry about the noise floor. What you're asking about when you're listening in a car, what you need in a case like that is something called dynamic range control, and that is in fact built in now to the latest version of the AAC codec, which is the extended high efficiency AAC, or XHE AAC. And so in fact, if you are as an encoder, if Streamblade is using XHE AAC, then we are actually required to do loudness control on that, and loudness metering is being done at the same time. And so all of this loudness content is being included as metadata within the AAC packets themselves. And that is being sent to the receiver, which is then making the adjustments required to.
Okay. So for instance, if I'm a classical radio station and I've got cuts where they're very, very quiet passages, and without some sort of special processing, they'd be lost to the ambient road noise in my car.
Right.
Does this solve that?
Well, our AGC and the limiter solves that.
Okay.
So it's quite interesting when we watch program material go through the Streamblade processor, and we just look at the output level after the 3 stages of processing. It doesn't matter what the program content is. The output level just kind of hangs there and sits inside this nice, sweet place where it's never too soft. You can always hear it. It's never too loud. It's never clipping. It just rides right there and
Well, and the
acts
other
like a,
important thing is from, Chuck was mentioning the loudness issue. And, if you look at the output of the stream blade processing on, say, a BS 1770 meter, it basically just stays within about 2 dB of a number, whatever number you pick.
Okay.
And the important thing is you don't really hear it making the changes required in order to hold it there. It just happens.
Right. Okay. That's great. So George has asked, what type of services can you suggest carrying on metadata?
what types of services?
Right.
I'm not sure I understand that. So traditionally,
I think for instance, if you think about the presentation that Rick Greenhut did earlier, he was
yes.
talking about album art, he was talking about content with regard to artists and all that kind of stuff. What is the range of services that you see people using in the future and today in streaming?
Right. Okay. So up to now, it has been primarily artist and title information. Depending on your server, it might the server might also accept information about the genre, the type of music the station is or the stream is broadcasting, things like that. Part of the issue with HLS, which has been around now for what, 3 or 4 years, is to be able to carry lots of different kinds of metadata. For example, album art or URLs to click for more information, just advertising information, things like that. That's carried by HLS. Part of what I said earlier about there not being any standard for metadata, the result of that has been that various distribution networks have created their own standards.
Sure.
And their own players as well. Part of the equation here is, can the player actually display metadata of various sorts? And it really depends on the player and what the player knows to look for. So it's kind of a dance that encoders play and CDNs play and players play, as we all have to work together to be able to display anything more than just artist and title.
Okay.
I hope that answers the question.
I think so. Marcus from Switzerland says, is there some kind of output stream monitoring or decoding of the coded output stream built in, or do we still need an external device for this?
So if you are on a WheatNet system, this is automatically going back into the WheatNet system. So all you have to do to monitor it is just make a cross point in Navigator and listen. If you are using the Streamblade as a standalone device, then you also have output, analog or digital output there that you can monitor from.
Okay, so that's like confidence monitoring, right?
Yes, exactly.
Okay.
And so what you're hearing would be the post-processing output. It's not the post-encoding output.
Okay, because that's what Marcus was asking about, is post-coding, because each of the coding algorithms have their own artifacts, right?
Well, they do. Yeah, of course, you choose coding algorithms to hide those artifacts, but we thought that the best way to listen to an encoded stream would be to listen to the encoded stream, just actually stream it back down and hear what it sounds like. So.
Yep, I get that.
Yeah.
Okay, so the answer to Marcus is really you'd need an external device if you really want to hear what it's sounding to the listener, sounding like to the listener.
Yes, and in fact, when we showed this at IBC last fall, that's precisely what we did. We had Streamblade running, and then right next to it, we had another computer receiving the same stream.
Mm-hmm.
although it was strangely enough, you know, it was being bounced from Amsterdam to California where the server was, and then back to Amsterdam where we're listening to it. So
Just a little bit of time delay,
with a bit of delay there, yes.
Yeah, yep. I'm curious whether Jeff has anything he'd like to add.
Just one thing, and it's something that may not be intuitive if you've been doing radio processing your whole life, like I originally was. One of the cool things about streaming is that the listener at the other end has no idea how long it takes for the audio to get to him and be decoded.
Right.
And the cool thing about that is that means that we don't care, which means we
Yes.
actually can look ahead to see what audio is coming in, be ready for it, process it, output it. And the process of that, it's why we call it neural network processing. It's basically looking at the stuff coming in is really ready for it. And it also has the history of the type of programming that's been going by. And that helps it adapt in a way that basically hides all of the artifacts you would normally hear when a limiter or a leveler is, you know, attacking and ducking the audio down. Those artifacts are completely absent.
Mm-hmm. Mm-hmm. Okay, but you wouldn't want to, or the negative to that, the gotcha to that is sitting at a ball game, watching the game live and listening on your headphones for the play-by-play.
Always going to be that way, isn't it?
It's always going to be delayed, isn't it?
It's the world we're in, I'm afraid. Ronan asked a question, is the unit going to be available on the Navigator in a Wheatstone network? I think you may have answered that.
Yes.
Yes. Yes.
Okay.
Yeah, his signals show up just like any other blade, and you can route any audio you'd like to the 8 inputs. And you know, like Rick had mentioned, each one of those 8 inputs has its own instance of EQ and processing, and each of those 8 instances can then feed up to 4 output streams.
Wow.
Right, and I might add, you don't even need to use the output streams. You've got it's an 8-channel blade. You've got 8 inputs, 8 outputs. You could, if you just want to use it as a processor for whatever, you can simply do that and not worry about a stream server out there.
How does streaming server technology compare with what's necessary for streaming or for processing, for instance, the HD secondary channels?
How does it compare?
In other words, what do you do differently? Should you treat an HD stream like a secondary HD2, HD3, HD4? How would you process differently for HD than you would for a stream?
You've got different codecs, first of all, so you're kind of keeping that in mind.
Yep.
But depending on the bit rate, there are things you would do. You would not try to shove too much of a payload through there if you're running very low bit rates. And that's one of the reasons why we have some of the tools in Streamblade that we have, because we know not everyone is going to be running 300K plus streams.
Right. Right. Okay. Very good. I do know that I have seen people processing for HD2, HD3, etc., using streaming type processors, and I was just curious how applicable those might be.
Yeah, but that's if I was still doing it in the field, that's exactly what I would do.
Yeah. Yeah. Okay. Well, thank you, gentlemen. I really appreciate it. This is very enlightening, and it's things I had never really considered before. So thank you very much.
Thank you.
You are welcome. It's been a pleasure to do this.